functionality. Of course, it's much more complicated than def plots. So I just wanted to show you that a type class will factor out common, very complicated behavior, like the implementation of replicate. What do you think?
Lost.
Lost?
Yep.
Okay, how can I help?
I think there's too much that I have to unpack to make it happen, unfortunately.
Okay.
There's just a lot of unfamiliarity with Scala. And
That's okay.
I feel like I saw in the reading, I saw an abstract class, and so what I feel like I'm basically going to do is be saying like def points, and then specify what the inputs to points are, and then leave it at that.
Let's see. Well, you get to decide what the input and the output of this def points are. That's part of the challenge.
Yep.
And realize that you have these types at your disposal here.
Domain range, and what is this T domain range?
T is also a generic type. It's a higher kind of type. It has two types within it.
Okay.
You should erase that equals question,
Yep.
because that is just to keep the thing compiling. And it will break the compiler, but that's okay. So you have to come up with some reasonable inputs to points and a reasonable output that is useful to this def plot function.
So you do have to come up with a...
You don't come up with an implementation for it. So you don't come up with an equal sign or anything to the right of the equal sign.
Just a type of the...
The inputs, or one or more, and then the output type.
Be.
Yeah. And how is it going to be useful to this function?
Yep.
So this is going to do a print statement here.
Yep.
I'll tell you.
What is this little string substitution looking stuff?
So I have a capability here of naming the output. So it's just a silly common functionality. I want to be able to put anything into this plottable and label.
There's name. Right. Okay.
And label what the plot is, so I can keep track of what's going on in the console.
Yep.
So I mean, the use case is asinine, but it's.
so Y is going to be my output.
Well, yeah, exactly.
Which results. So how come you have this commented out area here? So is it
I think that's a clue.
Yep.
So,
okay.
Yeah.
Right. So Y is going to be an output that goes to standard out. That's going to be the result of evaluating points. But evaluating points is going to be implemented differently depending on who decides.
The implementation of points, the concrete implementation of points.
Right.
The input, the types are going to be. I mean, the arguments are going to be same.
Right.
Although it might be a double sometimes, it might be an int sometimes. T is not going to always be T. It could be T is going to be a number of things.
What does T stand for? Does it stand for something?
No, it's a made up. It's a generic type. It could be anything.
Got it.
Any type that contains two internal types. Okay, let me point that out to everybody because that's really useful. Thanks.
Well, it's just I figured out how to use those two. It took me forever to figure out. In this case,
So I've neglected to explain T. This is generic, and T is also generic. What is in common between T and model and function 1? What is in common? Yeah, what might T be useful for? Or what do you think T is a stand-in for? Thank you. Hey, how's it going? Compiler errors, huh?
Doing the implicit stuff, man. I haven't gotten to this yet.
Got it. That's okay. I skipped past the part 5 because I figured everyone came here with type classes, so I wanted to be here to explain it in person.
I'm confused.
Yeah.
There's one thing. So this whole complex thing, so I'm supposed to have an implicit that converts an integer into this complex number? Is that what it is?
Let's see. Yes. Yeah, exactly. So in math, right, if you like turn a real number into a complex number, it has this imaginary component that doesn't actually exist. So you have like, I forget what it is exactly, but
Complex conjugate.
I wasn't actually getting that far. I just meant that the real number has a component that is unused. So the imaginary component is 0. So you can turn any...
Once you turn a complex number into a real number, yeah.
Oh, how about a real number into a complex number?
Well, it's always a complex number. It's just got a 0.
Yeah, so that's what's in the implicit conversion.
Okay.
Yeah. So it's not, there's no arithmetic in there. I'm certainly not doing, I squared is -1 or anything like that. It's just that I need to be able to convert on demand a real number into a complex number. So yeah, you hit the nail on the head. So.
You're lucky you're not a PhD. There you go. Yeah, so what's the... So then I call.
Can I help you guys at all?
Still don't really know what I'm doing.
Okay. So
So I don't understand still, like, so I get the structure we're using now, but I still don't understand, like, what I'm supposed to,
okay. So what you're doing there,
like, what is it supposed to be?
that is an abstract method. So you got it exactly in reverse, which is that what you're doing, you're providing the names of the values, but not the types. So when you implement an abstract method, well, actually, you can provide the names of the values, except they're not actually used for anything, because there's no implementation to use them here.
Okay.
So let's look at an interface in Java. Can you pull up a Java example interface?
What do you mean?
I'll just type it in Java example interface. We'll find an example of a Java interface, because this is the parent of all these concepts in Scala. Just the first result is good. Great. And then scroll down. Okay, so an interface is, that's a bad example because it doesn't have any types. Okay, this is a good example. It's like an abstract, it is a class that doesn't have any functionality implemented, except that it defines certain methods.
Sure.
So that is the same thing as an abstract definition in the Scala trait. One thing that they're missing here is that, this is also a bad example because they don't have a return type here. It would be better if they had a return type example. Imagine set home team returned a state or something, like the city that the team is in or something. I don't know, I'm just making it up. That's the concept of the abstract method. So
then like this might be like, I don't know, public float whatever.
Yep.
And then
and it's
some
up,
type.
and then anything
You
that
don't actually need the name.
well, by convention in Java you do, but it doesn't. The implementer of this abstract method gets to rename it anyway, so the name doesn't really matter. What matters is that what implements sport. Here's the example. Well, they're making another abstract interface on top of an abstract interface. So let's look at this one here.
Well, so I tried. Can I show you?
Oh yeah, look at mammal. Yeah, that's good. Okay.
Can I show you before?
Sure.
So I tried like, if I were to try to use points, I might do something like this. I don't know how correct that is.
Okay, no, that's fine. No, what you're doing there actually, to make an object is concrete. So to make an object, you provide, I can't sit down because I have these mics. Let's see. To make an object, you have to provide a concrete implementation. So it's, but you can only do that once you know what the types of def points are.
Yeah. So I guess for points, and that's another thing I don't understand. I don't actually know. So like, here's this thing that's points, right?
Uh-huh.
And I don't actually know what I wanted to return, if anything.
It should return something. Yeah, it should return
Right,
something. Yeah.
but it's like unclear how I'm gonna use this thing that I'm making.
It's going to be used in def plot.
Yeah,
right
but,
here,
But like,
points.
what is it actually going to be? Like, what is the? So it's gonna define y as being that, right? And then
Okay, here's
I
the
want
meaning.
Y to be.
Here's the meaning. Okay, we have this T type here, right? And this is a stand-in for either function one or model or anything other that has an input and output. And you might be wondering, for any T, how do I know how this gets into this,
First
right?
of all, I don't know what this notation means. So there's T.
Okay, this is another generic type. This is a generic type, generic. These two are defined over here. So these two are concrete at this stage of the.
But what does it mean to like say T?
Okay,
bracket,
okay, that means that this can be filled in. This can be filled in with any type that has two types inside of it. So T can be replaced with model, or it can be replaced with function one. Yeah.
So it basically means that it's required that whatever type you put there has to have a domain and a range thing.
Yeah, exactly.
Okay.
Exactly, yeah.
Okay, so it takes a domain, a range, and then a type that also has a domain and a range.
Exactly. And you don't, I mean, just from T, it tells us nothing, right? All it tells us that it has an input type and an output type. We have no idea how to transfer this into that. And that is what points is for.
Right.
Points is the actual way in which the domain turns into the range. For any T, yeah.
So okay. So then if I have like I guess a model.
Well, look at
It's just modeled. It's just like something like the return should be. I mean, it seems like the way that this transforms into the range is by whatever model does.
exactly, because this is the abstract portion of the type class, and this is the concrete portion of the type class. So this is going to vary by any implementation of plottable. And it's because a type class only makes sense if you have some something not in common.
Mm-hmm.
Because if it weren't, that's why this is abstract. If I had a common functionality for anything, then this could be concrete.
So the result itself should be the range,
Yes,
I guess.
yes, but not just a single range. There's one more tick to it. You're not going to get just one output. You're going to get a collection of outputs. Because it's meant for sampling. You put in a list of inputs and you get
Okay, so like some sort of vector, I guess. I don't know.
Oh yeah, exactly. Yeah, and you can look at there's a clue here.
I see.
Yeah, so
Maybe we should look at that.
it's okay. Was that helpful?
No, yeah. So I still think I'll eventually like. I think for me, what works really well is like if I have something where maybe we've sort of done something very similar, and then I can just sort of like try to
Sure.
do my own of something else that's kind of similar.
Gotcha.
Because
Well-
there's like a lot of like, I think a lot of the terminology and a lot of the steps are. I don't know. Since you know a lot more, maybe sort of take for granted. But since
I
haven't seen
appreciate.
any of it, it's
I agree.
like-
Yeah, no. Well, let's see. I can tell you a couple of close cousins. One's the adapter pattern, and that's referenced in. There's more resources than just that one blog post. There's links at the bottom of the README. If you search for Scala type class pattern, that's helpful. And people will tell you what like the lineage of this thing is. What's the closest cousin in Java? And so stuff like that. I hope that's helpful.
Because I'm thinking of mix.
How's it going?
Good. We got this working.
I don't know what
Great.
not me.
Great. Okay.
But I was curious about your earlier point that the whole point of all of this is to be able to extend classes without compiling. Well, in this case, without compiling what? In this example, you're definitely compiling the whole thing.
Oh,
How do you tie that all
without changing model or function one.
Right.
And also that if I want the common behavior of label making or plotting, I don't want model and function one to have a common ancestor. So the traditional way of doing this is with inheritance.
Got it.
And I would have to have anything implement
Well,
a
that's
label
right. It's
maker.
about enabling model to be plotted.
Yeah,
That was the
yeah, or
So you
enable.
have something behind the scenes that does what model does that you wouldn't have access to here. You just have the header in essence. Or the
Well, like the traditional way, my opinion of doing this would be, some common ancestor that implements plotting or label making
Right.
or anything. But we don't want anything that can be label made. label made.
And maybe an equivalent to this, if you were to do something similar and you only had C++, would be templates. Apply
Maybe.
that random to the class.
Yeah,
It
I
won't
mean,
work all the time, but that's kind of what they're
right.
for.
Yeah, I think so. And Java would be like the adapter pattern.
Yeah.
In Python it would be sugar.
Yeah, sure.
So
Okay. Yeah,
I think
encountered that.
so. There's some cousins to this.
Yeah.
But the one that really made this popular was Haskell.
Right.
So yeah, you see a mix of this stuff. I mean,
But
you
I don't
see.
see a whole lot of production products built in Haskell.
No, well, this pattern, the Scala Standard Library uses inheritance. It uses mix-ins. It uses type classes.
Yeah, I was thinking more mix-ins. That's also a way of kind of achieving this.
That's like inheritance. Yeah. I mean,
duck
you're,
typing.
well, let's see. I mean, mix-ins. If I have a list that inherits from indexed seek and from seek, that's the inheritance
Yeah.
approach, which is fine.
Yeah.
So why isn't everything in the Scala Standard Library done with inheritance? Well, a lot of it is, but in other Scala libraries, they move towards type classes. So,
Also like
yeah.
the old 22 field limitation thing, which apparently Scala itself has kind of gotten around, but I noticed is still there in cats.
Oh, you mean 22 generic types
Yeah.
or something?
Oh,
Oh,
22 fields.
oh,
that you can do
yeah.
stuff with.
That's funny. Yeah.
Like, what was that number? Why was it magic?
I don't know.
But
I don't know where it
just
came
how Scala
from.
started.
Yeah, that's funny.
It's the catch-22 of Scala.
Yeah, it's yeah. I haven't really
One of the
thought
first
out
times
the.
I countered that, I was like, is that just like, did someone just do this? Or is there some real, is this a
Let's see,
category
Harrison.
theory thing I don't get, Why
Yeah.
22?
No, I don't think there's any category theory reason for that. I don't know. They
The
just
main
sort of
thing
draw
that
the
threw
line
me off for
somewhere.
a little bit was to realize, for one, I had to, I don't know if everyone, including me, did all the studying to realize what math would need for parameters, right? But I kind of remembered, but what took me a little while was realizing, if model, I need to call .pdf to do
Yeah,
the thing.
yeah. So I just wanted
Around
to.
and around.
I have two things that could be plotted, which are
Yeah.
function one and
Yes,
model.
which was much easier
Yeah.
for me to code. It just took me a little while to go, wait.
No, it's fine.
Yeah, val PDF is defining a function. It doesn't do anything really in this example. I guess it does. It just says this thing becomes this
Well, you have to have a concrete model, and you have to have a
thing. Is
model
that
of
behind
doubles
the
to
scenes
doubles.
here, or did we not use it?
Let's see.
There's a new model with the Gaussian PDF, and that's what we use, and then done. Got it. No,
Yeah,
that's what
yeah.
finally tied it together for me.
Cool,
Got it.
cool. Yeah.
Got it. Got it. Yeah, that's right. That's what I was showing him earlier, too. So by itself, you wouldn't be able to do anything, but duh, because we defined it.
Oh, so the part we skipped over implicits, but the next part of this is that you start to define methods that assume an implementation of plottable, and that method defplotter
Yeah.
gets to exist outside of the type class, which is pretty cool.
Right.
So that justifies implicits in Scala.
Yes.
It also just implicits. There's two ways of. You'll see the colon type bound on like a generic.
Right.
So I say, give me A so long as there's a monad for A,
Okay.
something like that. So yeah. So I didn't mention 6D, but task
Yeah.
6D is a big part of this.
Fairly straightforward once you see it.
Cool.
Yeah, understanding why the implicit's there may be not as straightforward.
It doesn't have to be implicit. Yeah, I mean you can pass it in explicitly if you want. Here, let me answer that question though.
Oh, it's here when I call plotter. Okay.
When you call plotter, yeah. See, here's one way of thinking.
Oh, yeah, of course. Got it now.
Why are implicits useful? It's because the number of implementations of plottable is relatively small, but the number of use cases of defplotter is very high. So if you use an implicit, that's one fewer argument that you have to pass
Right.
with all the use cases of defplottable.
That's kind of
Yeah.
how I'm just interpreting it.
So the idea is to reduce characters of code
Right.
at the site of usage.
You're just going to write over and over the same darn thing.
Exactly, yeah. So most of the time, if you're using cats or Scala Z,
Different plottable, I could. But it's curried here. This is like a curry.
it's going to, it's going to fill in the plottable so long as there's an implicit in scope. Most of the time when you're using cats or Scala Z, you can rely on the library to provide the implicit instance for you,
Right.
which is cool.
Yeah.
So there's relatively few implementations of plottable, but there's a lot of use cases of plotter, yeah. So, but you're doing it all from scratch here. So you're acting as the implementer of cats or Scalzi.
Right.
So,
but if I wanted to not use the current plottable, I could still pass another argument here, right?
yeah, you could you could override an implicit parameter with an explicit, yeah, exactly. But it will figure out the type. So D, R, and T become concrete. Right. It's going to look around, give me a plottable of double and int, and
it will.
If it can, yeah, if it can find one,
I have to find it. Oh, which is the plot double function above.
Yeah, as long as that has the implicit modifier ahead of the object, yeah. So, but if it can't find the implicit, then it won't compile.
Yes.
So,
Yes.
yep. And you might also ask, okay, if I have two implicit objects in scope that have the exact same type, there's no way to disambiguate them. So the Scala compiler should tell you then too, I can't choose between these two. They're the same type. So that's another interesting question.
Yeah, figuring out why certain parameters are curried or not is something I got to get back into. I've noticed D is as well.
It enables the compiler to fill in certain parameters for you, just like it's filling in that implicit plottable for you. Oh. You can't mix implicit and explicit parameters in the same group of parentheses.
Okay.
Yeah, so that's fine.
But in this case, D double is not really. Where's D?
D double?
Yeah, where's it come from? In my call. Gaussian new model, there's a new model, Gaussian PDF. It's got two parameters. What would D be in this instance?
D is passed in from there, Gaussian PDF. So you give it a.
I got 1 and 2. But what is D?
D is supposed to be the x position, I think, on the Gaussian curve.
But in this case, what is the value going to be here?
Well, the output type is going to be the height of the Gaussian curve, the bell curve at that point, I think.
What actual value D is going to take on when this is occurring? D minus 0.
This is, he just said, it's a graph. It's going to be your bell curve.
Actually, you can't plot it. Yeah, try plotting it. It'll plot it out on the. Let's see. You got it here. So this is a bell curve. It's the highest.
Yeah, if you were to plot it out, it's going to be something like that. And it's a distribution. So
I get that, but what's D?
Oh, what was that?
The little letter D here is this kind of curried parameter.
Yeah.
But when I'm defining my model here, I don't provide a value for that. So what is the value?
It's fed into it by. Scroll down to plot example.
Oh, okay.
Yeah, it's fed in down there. So I give -16 to 16.
Oh, okay.
Yeah, there you go.
Okay.
Well, power. I don't know what power is.
Oh, okay, and then it's calling plotter and blah, 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 which is going to fill in that argument.
Yeah,
which is gonna
yeah,
call-
exactly.
Okay.
Yeah. So you're making an instance of Gaussian that has those two parameters baked into it.
Oh, yes.
Variance and mean. Yeah.
Yes,
So
yes, okay.
cool.
That always throws me.
No worries.
That's why I'm still that's why I'm here, 'cause I'm still a Scala noob, even if I've coded it.
Cool.
No, that's what I was trying to figure out, is like, where does D get defined? I get what it's doing.
Could I ask a question?
Sure.
If I were to be working
Let me come around. Let's see. Sorry. Give 1 second. I gotta answer this question. Hey.
So if I wanted to work through, this or one of the other kind of exercises we have here, in the meantime before we meet again, is there a place where I can look at completed progress files, sort of, or even a completed whole file?
Oh, let's see. Well, I don't give out the answers,
Right,
my own
exactly.
answers. I mean, I guess you can look at other people's answers if you want, but it's, is that what you mean?
Yeah, exactly.
Yeah,
So if
yeah.
I wanted to look at lecture 3 or something, because I won't be here or something like that.
Gotcha. Let's see. Well, I'm going to try and get in the habit of releasing the exercises earlier, but it's up to, we got to talk to the team about releasing the answers, because I think we have a policy of not giving out the answers. I don't know, maybe we have to give them out later or something. I just haven't thought about it very much. You're asking for answers though, basically, right? So I'll consider it.
Basically, yeah.
Yeah, okay.
Yeah, I get not before the class. That would make sense too.
Sure. Yeah. Cool. Yeah. Well, I'll the least I can do is, I mean, I'll keep nudging you guys in the right direction in person here. So I'll talk to Chris about it. And he'll make a decision.
Points, right? And in here, our function is the model. And if you look at the model, that function is actually defined as that PDF.
Okay.
So if you have a model object like t here, if you do t.pdf, you would get to that function.
Let's see. Yeah, that's right. Yeah, that's how. I mean, it's a little bit different than function one. Not that different though. I mean, they both have an input and an output.
Okay.
Yeah.
So that means to say if I have this model that we refer to this class, and automatically it will map to this function.
Not automatically. You have to like call that. So that value here, that PDF, is a function. You see the signature PDF, it goes from domain, a type of domain, and to a type of range.
Yeah.
So that's a function, right?
Yeah.
So if you do t, which is class model,
Yeah.
t.pdf, that calls this function for whatever you implement.
Can I get one of these?
So that.
Yeah.
So I basically haven't made any progress, but I kind of want like more.
You do, yeah.
Like I think for me, there's definitely very many gaps to fill.
Well, I had to skip over some things too for the sake of time, so I hope that.
So I
Sorry.
think since I don't have a ton of time, I basically don't know where to go from here, like at all.
Gotcha.
information-wise.
Okay.
I tried to sort of do this. I don't know if this is right, but I tried to do that. But if it isn't,
That's okay. Okay, this is mixing Scala and Java syntax here. So this that's just okay. This belongs over here. It's colon list, and list has to have a concrete type inside of it, right? So it's a list of something.
Say list T? Is that what you do? Because you don't know the type?
Not T, but close.
sorry. And what was the other thing you said? That it's got to be the type of what's in the list.
Yes, exactly.
So it's a bunch of domains, I guess.
Well, I think range is the output, right? Range. Yeah.
Oh,
Is it-
right.
Yeah.
Right.
Yeah.
Okay.
Now, I was wrong. I misled you earlier. That you do have to have names here for these variables, even though they don't exist, even though it's totally abstract. So you just name it anything. You can call it F and D or something.
Well, I guess it's all again.
That's fine. And that's also a mix-up of Java and Scala syntaxes. And in Scala, the name goes on the left colon type, the name colon type, like that. Yeah.
Turns out I'm actually no Scala.
That's okay. That's fine. No worries.
I'm mostly done. Hold on. Here, I guess I'll call it input because that's what we're calling it down there. Yeah, mostly done C# type stuff with object-oriented stuff, and it's
Cool.
very similar to Java, I guess, because the output definitions go there. Okay, so this is good now.
Yeah. So now you figure out how points is useful to this. Everything in here is concrete.
So here's the next thing I don't understand.
Yeah.
So typically when I do something like this, and what I'm used to, I've defined this thing, and then I have a class, a subclass that might want to use this thing that I defined in like the standard kind of like object-oriented scheme.
A subclass that might want to use this thing. Okay.
So like I have a big, the thing we didn't want to do, right? I have this really big overall class, and I'm going to define these methods in it, and then things are going to inherit that, right? And the way I'm used to then defining what this will do is by doing some sort of override, right?
Yeah. But that would mean that all these things have to have a common ancestor, which is what you're trying to avoid. Yeah.
And we don't want to do that. I get that.
Yeah.
So now what I don't know is like now that I've done this, I don't know how to actually define what it does in each of the things I want to use it for.
Define the thing that it. Okay, that happens down here in the concrete instance of plottable.
Right. So I had tried doing that down there, right?
Okay.
I think you told me it was wrong. But I had done something like doing I forget what I did.
Oh, it doesn't have to be override. The convention is that if you're overriding an abstract definition, it's not really an override. So it's just def points, and then the same signature, and then equals, and then you have your concrete implementation on the right side.
Okay, so I can just do this or whatever, right?
Well, it has to have the same signature as def points up there, so you have to implement that exactly.
Okay.
Yeah. However, there's one more trick here. There's one more trick is that this, you're dealing with a plottable of double model, right? So you have to fill in the blanks up here. It's double model. You no longer have a domain and a range and a T. You have a double and a model. Yeah.
Okay. So So in this case, this would just be model,
T would be the model, yeah.
and then so here's the model, and then what I do here, I have the input was the domain. So I guess in this case, if I do input, I could wait. I think I know.
Cool. Now you do have to define the two types inside a model.
Right.
Yeah, so.
Yeah, I was gonna say I think I need to go back and do that. So,
Yeah.
but then here will be double,
Yep.
and then I can go back here and do double.
Yeah.
And then this thing needs to output a list, which is gonna be double.
Uh-huh.
And then I guess I type what it does in here.
Yeah, that is concrete. Yeah. So look at the type of the model class, and you'll figure out how to implement that method.
Sorry, look at.
Oh, here's model, class model, class model.
To the main range. I don't think I will figure out.
Let's see. So put a colon here.
Oh, sorry, that's just.
It's okay. It's okay. So basically, I think what the confusion is that, see, you see this as something that doesn't have an implementation, but it does have an implementation if you have an instance of model. So you're coding against any possible instance of model. I could have a double-double model or a double int model or anything, and then that is going to implement this. So this is like an argument to construct the class. If I want a model, I have to provide a concrete implementation of this, and then I get to use it. So I get to do model.pdf. This is going to be a concrete method here, from a double to a double.
Sorry.
So, well, let's see. Let's look at an instance of model. Let's go down here to Gaussian model. This is a model. It has a method in it. And what is the name of that method?
Oh, right. So I guess.
I joined just.
No, join us. Yeah.
Okay. So.
If I wanted to get at the Gaussian PDF, it.
So then, so this. So PDF is what kind of thing is PDF? It's some sort of method, I guess.
Yes, it's just a function. Yeah, it takes in a domain and spits out a range. In the case of the Gaussian PDF, it is going to do type inference.
Right.
It's going to infer that the input type, the domain of the model, is a double, and the output type is a double. And it's able to do that because it's really smart, and it follows the chain. It figures out Gaussian outputs a double. I'm inputting doubles here, and it's going to figure that out for you. So.
Okay, yeah. So then the model defines whatever the PDF is, and then if I wanted to do a point for that, it should then. I mean, I guess I don't know how to what the. Okay, so I understand that this is some sort of method, and that method. Like in this case, where is it? Takes in the. Why is it taking two things in here?
Those are the parameters of the Gaussian distribution.
Oh, I see.
Yeah, it's a little bit overly complicated. I could have
So
fixed
this is
those.
the one actually.
Yeah, that's right.
Okay,
So this is also an example of currying, because let me show you. When I apply these two parameters, there's one left over there, and so that matches the signature that this expects up here. Whereas it has an input and an output, and if I didn't have this third parameter here, it wouldn't match that, and then I couldn't construct a Gaussian model.
Yeah. So this is the one that I'm interested in, and this one is the domain one.
Come on.
Huh?
The day 2. Come on.
Day 2? I'm.
Okay, so then what I want is that this should be another sort of abstract kind of thing, or I don't understand.
Oh, very concrete. And it's going to be concrete. Yeah. So you're going to plot any model that takes in a double and outputs a double.
So I mean, it's gonna just take this and it's gonna take in
Whereas PDF, it doesn't just live in space. It exists inside of something
it
that you have in scope.
space.
No, you just call it PDF, and it doesn't. You can't
Oh,
get it.
this is not part of that.
No.
Oh.
No, but you have everything you need in those arguments there. You have a model and you have an input.
So if I do,
That would be good. Sorry, go on.
this might be totally wrong, but I was just wondering, can I do things like this or something?
No, because that is like a semblance of like a static method in Java. Good question. And that does show up in Scala too. That would be like a method that's shared by every model, which does exist. It doesn't exist in this example. But right now you have a...
PDF is not shared by every model?
No, because each one of them has a different PDF.
Oh.
So domain and range are generic, like abstract types, and they're gonna, depending on what the model is,
So how can I reference that then?
because you have an instance of model passed in there as an argument, and it's called T.
Oh, my key.
Yeah, exactly. So.
So in that case, can I do that?
Yep.
Okay, great. And so then, do I need to then also specify those, or does it know? Because I said T.
Let's
so
see.
in this case, I can do that. I think I need the double from here, right? So.
You know what? Actually, I think your signature of points is slightly off. It has to be a list of inputs, not just a single input. Let me double check here. Yeah, make it a list of domains, not. Yeah, and that means you have to change it up there in the type class as well. There's no way to produce a list of, well, unless I just copied the single output 10 times into. So it wouldn't be a very good sampling. Then it wouldn't be a very good.
No, that makes sense. Yeah, I actually don't know how these domain and range things are defined, so I just sort of didn't pay too much attention to that. Okay, so then for my okay, so I have the T, and then this one.
I think your syntax is a little bit wrong there. It's parentheses, not brackets. Yeah, you're right. And at the site of application, you don't have to define the type of the input. So what that resembles is like you're defining a new function that takes in a double. But this way,
But in this case, it just already knows.
Oh, you know what? There's a hint in the README. Show me the README for task 6b. There's one more step here. Look at 6b in the README, please.
Oh, the README.
Yeah, sorry. Yeah. Over here. There we go. Now go to 6b. You need a function called you need map. So you either of those. Yeah. You have 6d and 6c. You have a function that takes in a single input, and you have a list of inputs. So you're going to use map to take care of that. Yeah, like JavaScript. Yeah. So your PDF can only take in a single input at a single time, and it gives you a single output, right? But you have a list of inputs and you want a list of outputs, so you're going to use map. Yeah.
Sorry, this is a function you're defining here.
It's not defined; it's given to you by list.
Oh.
Yeah.
So anything that's a list has.
Exactly. Yeah. Exactly.
Okay, so then if that's the case, I want to pass in here my input, I guess.
Mm-hmm. Actually, the map is going to go on the outside, so the map is going to call the PDF. You'll see.
Yeah, I don't know how.
Oh,
So
it needs to apply that function.
Yeah. So right. So where does
Input.map to call the PDF.
So input is a list, right? So